Hello everyone. In the last session, we have started with the curve tracing, and that we have started with the tracing of Cartesian curve. And the first point to trace the curve, that was to see whether it is symmetric about x-axis, y-axis, or opposite quadrant. And we have seen some examples based on that, right? Now the next point is we want to decide whether on the given curve passes through origin. If it passes through origin, immediately I'm going to figure out what is the tangent at the origin, right? If origin is not there and we got some other point, and how to find out that other point, we are going to figure out using intersection of that curve with the coordinate axis. From coordinate axis, suppose I got some point in the intersection of the coordinate axis and the given curve, then at that point I am going to figure out tangent. So note that whenever you got some point, at that point we are directly going to figure out tangent, okay? So that using the tangent I can decide that the shape of that curve, right? So tangent is pretty much important to trace the curve, okay? So in this section we are only going to concentrate on this point, right? The point here is, the first thing I am going to check whether the origin lies on the given curve or not. How to check that? Suppose some curve is passing through origin, that means 0 point lies on that curve. If 0 point lies on that curve, that means if I substitute x is equal to 0 and y is equal to 0 on that curve, then I should get 0 back. So what does this indicates? If the given curve does not contain any constant, absolute constant means, suppose the curve is like, say, y square is equal to 4ax, right? So here there is no just constant and present here. And suppose we have an example here, y square is equal to 4x. There is no absolute constant here. What is the meaning of absolute constant? Suppose if I added c here, so that c will be just constant term here. But now since there is no constant term present, absolute constant term present here, and I substitute x equal to y equal to 0, it satisfies that equation, I get a 0 back. So that means for in this curve, origin present, right? That means the curve passes through the origin, right? So if the curve does not contains absolute constant, so in that case the curve passes through origin. Once origin lies on the curve, the second point you are going to figure out is tangent at the origin. So how to find out tangent at origin? You need to equate the lowest degree term. That means if 1 degree terms are present in the given curve and there are two terms of 1 degree, then you need to consider these two terms together to equate it to 0. Now for example, I have one example here, y square is equal to 4ax, right? So now here in this equation, the lowest degree term is equal to 1, right? So lowest degree term is equal to 1. What is the lowest degree term? So 4ax is the lowest degree term, right? Lowest degree term, correct? So if this is the lowest degree term, what is my condition to find out tangent? Substitute lowest degree term is equal to 0. Once I substitute lowest degree term equal to 0, I get x is equal to 0. X is equal to 0 is nothing but y axis. So that means for this curve, tangent line is y axis, right? Firstly, I'll check whether curve on the curve origin present is present or not. If it is present, then I'll directly find out tangent at origin. How to find out tangent at origin? Substitute the lowest degree term is equal to 0. If there are more than one terms of the lowest degree present here, then take all that terms together to substitute it equal to 0, and by using this equation I'm going to get tangent for the given curve at a origin, right? And the next thing I'm going to figure out is the intersection with coordinate axis, right? Clearly, if I want to find out intersection with x-axis, on x-axis you know that y term is 0, so substitute y equal to 0, and on y-axis x terms are 0, so that means you need to substitute x is equal to 0 to find out intersection with y-axis. Okay, in next cases I need to express that as y equal to f of x and x is equal to f of y. Here it is not compulsory to express that in terms of f of x or f of y, so you can just go with by substituting only these two conditions. Okay, so in this section mainly you are going to check first thing whether origin is there or not. The second thing, if origin is there, find out tangent at origin. The third thing, intersection with coordinate axis, and that's it. Okay, this is your second step. Okay, so now here I am having my first example, right? The first example is y square into 2a minus x, this is equal to x cube. I want to check whether this is passing through origin or not, right? So note that there is no absolute constant present here. 2a is present, but 2a is multiplied by y square, so no absolute constant present here. Clearly origin lies on this, and I can verify this by using the equation that substituting x is equal to 0 and y equal to 0 in the above, right? In above. Or you can simply see that no absolute constant present here. No absolute constant. But if someone is not understanding what is absolute constant, it's okay. You can just substitute x is equal to 0 and y equal to 0 in this equation, right? So since x is 0, y is 0, yes, I am getting back f of 0, 0 as 0. So that means the conclusion is no constant present here, right? So since it is not without constant term, so that means given curve passes through origin. Right? So since given curve is passing through origin, so the next thing we are going to figure out is, this is your first point. A point is checking whether origin is there or not. The second point, since origin is present, you are going to figure out tangent at origin, right? So to find out tangent at origin, what is the thing? You need to substitute the lowest degree term is equal to 0, right? What is the given curve? Let's simplify that. Given curve is 2y square a minus xy square, this is equal to x cube, right? What is the lowest degree term here? Degree of x cube is 3, degree here is 3, and degree here is just 2. So that means this is your lowest degree term, right? So to find out tangent, let's substitute lowest degree term, this is equal to 0, right? So therefore this is 2y square a equal to 0, right? So what does this imply? Ki y is equal to 0. So y is equal to 0 meaning x-axis is tangent at origin to given curve, right? So two things verified. Now to verify the next thing is you need to check intersection with coordinate axis. That is, you need to substitute To find out x intersection, you need to substitute y equal to 0, and to find y intersection, you need to substitute x is equal to 0, right? Let's do this. Okay, so the next thing is to find out x-axis intersection, right? So put y equal to 0 in the given curve, right? Now in the given curve, when I substitute y is equal to 0, what it becomes? Left hand side becomes 0. What remains? X cube is 0, so this is nothing but x is equal to 0, right? And to find out y-axis intersection, what you are doing? Put x is equal to 0, right? So when you put x is equal to 0, x is 0 here, x is 0, what remains? 2ay cube is 0, so clearly y is again 0, right? So when x is 0, y is 0, x is also 0, and when x is 0, y again 0, right? So 0 comma 0 is the only point in the intersection, right? So the intersection with coordinate axis is the single point, and that is nothing but 0 comma 0, right? So 0 comma 0 is the only point of intersection with coordinate axis. Okay, so that's it. Only these 3 points you are going to verify in the step 2, right? Let's take some other example. Let's take a second example, and that is equal to x into x square plus y square. This is equal to a into x square minus y square. Let's take this example. Okay, first thing you are going to verify is whether origin lies on this or not. To find out origin lies in this or not, let's substitute. Put x equal to 0 and y is also equal to 0, right? So in given equation, given curve, right? So in given curve, when substitute these two quantities, x is 0, y is also 0, clearly it becomes 0, right? So what do we have? F of 0, 0 is clearly is equal to 0. That is, this is free from constant. Free from constant. So that means given curve passes through origin. Passes through origin. Right? Now once you get origin, the next step is to find out tangent at origin. Tangent at origin. How to figure out the tangent at origin? You need to substitute lowest degree term equal to 0. Right? Now note that what is the given equation? So this is equation 1. Now the given thing is x into x square plus y square. This is equal to a into x square minus y square, right? So just multiply here by x inside. So this is x y square. This is a into a is just a constant, this thing, right? Now when you try to verify the degree of each term here, degree of first term is 3, degree of second term is 3 again, degree of this term is 2, and degree of this term is again 2. So that means this both terms are lowest degree terms. So I need to take them together to equate it to 0. So from 1, what do we need to do here? substituting lowest degree term is equal to 0. So that is, you need to substitute a into x square minus y square is equal to 0. Don't have any information about this. This cannot be 0. I'll just consider this is equal to 0. So x square minus y square is equal to 0. So what does this imply? X square is equal to y square. So what is x? X is equal to plus or minus y, right? So that means two lines. These two lines are tangent to the given curve, right? So at origin you are having these two lines as a tangent, right? So that's why to decide shape, this tangent thing is pretty much important, right? Because of this, the curve may be like this, right? Because you are having tangent at origin, or the curve may be like this, because this may be a common point and this thing may be a node thing, right? Yeah, we'll come back to this later on, but just for now, why tangent is important? To decide the shape, the tangents are pretty much important, right? So tangents at origin are this thing, right? Yeah. Then the next thing we want to figure out is intersection with both axes, right? So C part is to find out intersection with x-axis intersection. You need to substitute y is equal to 0, right? When you substitute y is equal to 0 in the given equation, what do you have? Y is equal to 0, so this is x into x square, so x cube. This is equal to a into x square. So what is it? X square you can take common, so this is x minus a, this is equal to 0. Shift this term to this side and take x square common, you will get this equation. So what is the thing? X is equal to 0 or x is equal to a, right? So when you substitute y is equal to 0, you are getting these 2 points, right? So what are the points of intersection with x-axis? Points in intersection with x-axis, we are getting 2 points. These are, when you are substituting y is equal to 0, first point is x is 0. And what is the second point? When you are substituting y is 0, the second point is x is equal to a. So I am getting these 2 points here, right? Now what is the remaining thing? To check what is the intersection with y-axis, right? So y-axis intersection. In this case, what you need to do? You need to substitute x is equal to 0 in the given curve, right? So when you substitute x is equal to 0 in the given curve, what is the remaining? Left hand side already becomes 0, since the left hand side is x into x square plus y square. So left hand side becomes 0 since you are substituting x is equal to 0. So what remains? X square is also 0. So remaining part is a into minus y square is 0, right? So this is minus a into y square equal to 0. What does this imply? Y is equal to 0. So 0, 0 is the only point of intersection with y-axis. So with x-axis, 2 points of intersection 0, 0 and a comma 0, and with y-axis only 1 point, and that's it, right? This is the second step. Okay, let's take one more example. Let's take third example as xy square is equal to a square a minus x, right? This is the next example. Clearly, when you write down the equation as xy square is equal to a cube minus x into a square, clearly absolute constant is present in the equation. So 0, 0 will not satisfy this equation. So that means this curve does not pass through origin. Okay, since absolute constant is present here, this curve does not pass through origin, right? So since given curve contains a constant, it does not pass through origin. Since origin is not on the given curve, so there is no point of finding tangent, right? Origin is not there, so tangent is not there. So directly go with intersection with x-axis and y-axis, right? This is E part, and directly go to third step, that is finding intersection with x-axis and y-axis. So x-axis intersection, now to find out that by substituting y is equal to 0. When you substitute y is equal to 0 in the equation, what do you have? A square into a minus x, this is equal to 0. Clearly a is not 0, so what you have, x is equal to a. So therefore a comma 0 is the point of intersection of x-axis and given curve. Right? Then the third thing, you are going to find out y-axis intersection. To find out y-axis intersection, I need to substitute x is equal to 0, right? So when you substitute x is equal to 0 here, what you have, just a cube is 0, a must be 0. This is just absurd. A cannot be 0 if a itself is 0, so there is no point of that equation. Yes, so this cannot happen, right? So given curve does not intersect y-axis at all. Okay, it intersects only x-axis. Okay, and that's the thing. So I'll quickly summarize the point 2. The point 2 is verifying whether the origin lying on the curve or not. If it lies, then find out tangent. If it does not lie, then there is no point of finding tangent. Once you find out tangent at origin, go to intersection with x-axis and y-axis. Find out the point of intersection. Okay. Once you get point of intersection, you need to find out tangent at that point as well. Okay. We'll see that in the next coming sessions.